Next week we will do the AP pre-calculus pilot exam. So and I'll talk to you more about this before we go. So what we'll do is we will measure our distance from the center of the tree in this case. We'll measure the angle to the top of the tree. Okay, and of course, ideally, if we can measure the angle to the top of the middle of the tree that lines up with perfectly right angles with here. So we're not going to get very, very accurate answers, but we'll get an idea of how it works, okay? Because it's hard to even just find the level ground that we can get a right angle at like that. But that's what we're going to do. We'll talk more about that. But so next week ought to be a kind of a fun week, okay? Excuse me. Okay, so let's jump back into our packet. And we're going to look up here at some common right triangles. Now, you learned this in geometry. Let me rephrase that. You were taught this in geometry. Whether you learned it or not, I don't know. Okay. So these common right triangles, you should know these right triangles. You will most likely see these pop up on the SAT somewhere. Okay. And you may not even recognize that they're there, because if you didn't recognize them as one of those common right triangles, then you didn't use it to benefit you. It can save you a lot of work if you recognize that it's there. Okay. So first one is a 45, 45, 90 triangle. Since a triangle has 180 degrees, and we know that this angle right here is 90 degrees, then we know that the other two have to add up to 90 degrees. Well, one of them is 45, so we know the other one's 45. Okay, hopefully that makes sense. Okay, the ratio of the sides of the triangle will stay the same regardless of the actual length. Okay, the ratio will stay the same. And the ratio is expressed in different ways depending on what books you're looking at. But for me, I'm going to make the legs have a value of 1. Okay, the legs are the two sides that are not the hypotenuse. Okay. Since we have a triangle that has two angles that are the same, then the length of those sides will be the same. Right? That's one of your things from geometry you should have learned, right? So this angle points to that side, so that's the angle that goes with it, or the side that goes with that angle. And this is the side that goes with this angle. Since these two angles have the same measurement, their corresponding sides should have the same measurement. And if we were to use Pythagorean theorem at this point, we would find that this third side has a measurement of the square root of 2. This is just the ratio of the triangle, okay? So for instance, let's say that this side had a length of 5, okay? Now this is the type of question you would see on an SAT. It would give you a triangle like this, okay? It would give you a triangle like this, and it might say, okay, there's the information they give you, and it might ask you for the hypotenuse. Again, you can do this without knowing the 45, 45, 90 ratios, because most likely, because you guys are all smart, you would figure out, oh, that's 45 degrees, and you would probably figure out that would have to be 5 there. And then you'd use Pythagorean theorem to come up with 2 square root of 5 on that side. Okay, but on your SAT, one of the biggest problems that students have with the SAT in the math section is having enough time to finish it, right? Look at the ratio, 1, 1, square root of 2. Whatever the length of this side is, the hypotenuse is that number. Whoops, I just put the wrong answer there. Sorry. The hypotenuse is that number times the square root of 2. Because that's the ratio, 1, 1, root 2. So whatever the leg is, The hypotenuse is that number times the square root of 2. And does not save you a lot of time. You look at it, 45, 45, 90 triangle, right? And on the SAT, they're like, okay, well, this side is 27. What's the hypotenuse? And you're sitting there, okay, 27 squared plus 27 squared. Okay, now take the square root of that. You're like, blah, 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 right? You don't have to. This is simply 27 square root of 2. I didn't have to do any calculations because I know the ratio of a 45, 45, 90 triangle, okay? Now let's go ahead down here and let's fill in our sine, our cosine, and our tangent based off of the ratios that I gave you, 1, 1, square root of 2. Okay, so sine of 45, sine is opposite over hypotenuse. So that's going to be 1 over the square root of 2. And of course, we have to simplify this. So remember my rule for simplifying. Move, so move it up top. 1 square root of 2, we don't have to put the 1 there. Remove the square root from the bottom. So square root of 2 over 2. Okay. Cosine on a 45, 45, 90 triangle, sine and cosine are going to be the same because it's the same angle, which means the side lengths are the same. So we're looking again at the square root of 2 over 2. Cosine is the adjacent over the hypotenuse. Okay. What's the tangent going to be? 1. Tangent is opposite over adjacent, so it'll be 1. Okay. Okay. The other triangle. I've got a 30 degrees here, so what's that make this angle up here? 60. This is a 30, 60, 90 triangle. You just have to memorize these ratios. I always have trouble with this one, and I'll tell you why. Okay, I'm going to make the shortest side, the one opposite 30, that's going to be 1. In my mind, I'm like, well, if that's 1, then the one opposite 60 is going to be 2, right? But it's not. Okay, and it bugs you, right? We're going to put 2 on the hypotenuse. And then on this long leg, we're going to put 3, right? The shortest leg is opposite the smallest angle. Okay, the longest leg is opposite the largest angle. The hypotenuse is always the longest leg on a right triangle. Okay, now one of the things that I do, because sometimes I do doubt myself with whether I labeled it correctly, because it just, in my brain, it doesn't match. It's like I see that 30 and 60 degrees and I want to label the 1 and 2 accordingly, but it doesn't work. You just do a quick Pythagorean theorem check. Square root of 3 squared plus 1 squared, does that equal 2 squared? Well, the square root of 3 squared is 3 plus 1. Yes, that equals 2 squared, so it's labeled correctly. Okay. Once again, okay, memorize the ratio. 1, 2, square root of 3. Okay. The other way that you can check to see if you labeled it correctly, remember I said the smallest number is opposite the the smallest side is opposite the smallest angle. The largest side is opposite the largest angle, right? Well, if I look at those 3 numbers, 1 is clearly the smallest, so that's going to be on the shortest side. Well, 2 is larger than the square root of 3. 2 is larger than the square root of 3. How do I know that? If I were to represent 2 as a radical, what would it be? Square root of 4, right? So 2 is the largest number, so that should be on the hypotenuse. Okay, this is how you can remember how to label it. So once again, on your SAT, when it has a 30, 60, 90 triangle like this, right? And we've got this side labeled as 10, and it's asking for the long leg, it's going to be 10 square root of 3. I don't have to do any work. If it's asking for the hypotenuse, right, the hypotenuse is 2 times that side, so the hypotenuse would be 20. See, we didn't have to sit there and do all this complicated Pythagorean theorem calculations. We just know the ratio, okay? What if they gave us a 30, 60, 90 triangle, and on this side we had 50? What would the short leg be? 25. What would the long leg be? There you go, 25 square root of 3. Look how fast we did that. Okay, I know that you could reason it through and you could come up with the answer, but look how fast that was, right? You just have to know those ratios. Okay, this is also a 30, 60, 90 triangle. It's just oriented differently. But again, the short angle, the small angle gets the shortest side. The largest angle, which is 90 degrees, gets the largest side. So that's 2 over there. And then we put the square root of 3 right there. Okay. All right, I want you to I'm going to give you just a minute or two. I want you to fill in these 6, sine 30, cosine 30, tangent 30, and then sine 60, cosine 60, tangent 60. Okay, if you need to talk with each other, that's fine. Okay, sine of 30 degrees. Gavin, what's the sine of 30 degrees? The sine of 30 degrees. Sine is opposite over hypotenuse. So it's opposite over hypotenuse. What's the hypotenuse? 2. Opposite over hypotenuse, 1/2. But the cosine of 30 degrees. Ariel, what'd you get? Square root of 3 over 2. Make sure you say square root, because now that we're more advanced, there's more than one radical 3. It could be a cube root of 3, it could be fourth root. Those are all radicals, right? So make sure we say square root so we know which radical we're referring to. All right, tangent of 30. So this is opposite over adjacent, 1 over root 3. Can't leave it like that. We've got to move and remove. So move and remove. Square root of 3 over 3. Okay. Now you'll notice that when you do the 60 degrees, sine of 60 degrees is the same thing as the cosine of 30 degrees. Okay. Cosine of 60 is the same as sine of 1/2. Tangent of 60, so that's going to be the opposite over the adjacent, so it's just a square root of 3. Okay. All right, questions so far? Are you waiting for the hard stuff? Are you getting bored? Okay, let's look at this example number 2. Did we already do it? Oh, good. Moving on. All right, take out your calculators to make sure that you can do these in your calculator. Okay, everybody take their calculator out. All right, cosine of 30 degrees. Let's show you how to do that on your calculator. First off, we need to make sure that we are in degree mode. So press the mode button on your calculator and make sure that degree is selected down here, not radian, okay? To find the cosine of 30, if you look on your calculator, right above the parentheses, there's a cosine button. We're going to press cosine, and we're just going to put 30 in there. Okay, we get 0.866. Now notice that when we did the cosine of 30 up here, what did we get? Square root of 3 over 2. Is that the same thing? Well, let's check it out. Square root of 3 divided by 2, 0.866. Okay, so if you're asked to approximate this cosine of 30, then we can give the answer that we get on our calculator, right? Because this is an approximation because we have to round it. Everybody paying attention? If we're asked to approximate, you can give the answer from your calculator. If you are asked for the exact value, then you give square root of 3 over 2. That's the exact value of the cosine of 30. Okay? Everybody got that? Okay, so this is approximately, squiggly line, 0.866. We're going to say go ahead and round to 3 decimal places, okay? All right, skip the tangent of 90. We're not going to talk about that right now. Let's look at the sine of 45. I want an approximate value. Sine of 45. What you get? 0.707, right. So we're approximately 0.707. Okay, let's skip down to cosecant. If you notice on your calculator, there is no cosecant button. Well, what do we know about cosecant? It's the reciprocal of which one? Sine. So this is equal to 1 over sine of 45. Okay, and that's how we have to put it in our calculator. 1 divided by sine of 45. And we get 1.414. Approximately 1.414. Okay, go ahead and figure out the cotangent of 45. Cotangent of 45. Okay, so this is going to be 1 over the tangent of 45, which is what? 1. And we don't have to say approximate because it is an exact value. We did not have to round. Okay? Okay. Questions? This is 126. Is that one way? Okay, so let's see. We have a right triangle with a hypotenuse of 8. Okay, so let's draw our right triangle in there. Okay. Here's my right triangle. We have a hypotenuse of 8. Includes a 36 degree angle. Okay. So that means the angle that the hypotenuse makes with a side is 36 degrees. And actually, I probably labeled that wrong. So why do you think I'm going to put the 36 degrees up here? Why do you think I'm going to do that? Because the other angle is going to be bigger, right? The other angle is going to be 54 degrees. So I want the small angle pointing to the shorter side. Okay, I want the small angle pointing to the shorter leg. All right, find the lengths of the other 2 sides and the measures of the other 2 angles. Well, we found the other 2 sides, the other 2 angles. Now we need to find the missing sides. All right, so I'm just going to label this A and B. Okay, so let's figure it out. Okay, I'm going to work with side A first. So I'm looking at side A. What other side do I have? The hypotenuse. So which 2 sides are these in terms of SOHCAHTOA? Is it adjacent, opposite, or hypotenuse? I have if we're looking at 54 degrees, I have the adjacent side and the hypotenuse. So which function would I use? Cosine. So we're going to say the cosine of 54 is equal to the adjacent over the hypotenuse. Okay. So in order to solve for A, I'm going to multiply both sides by 8. 8 times the cosine of 54 equals A. So we're going to go to our calculator, and we're going to do 8 cosine 54, and I get 4.702. So A is approximately 4.702. Okay. Okay. Now, we're going to look for side B. Before I do that, could I have used the 36 degrees? Could I have worked with 36 degrees instead of 54? Look at this triangle, right? If I worked with 36 degrees, which two sides would I be looking at? The opposite and the hypotenuse. So I could have done sine of 36 equals A over 8. And I'm going to get the same answer. Multiply both sides by 8. I'm going to still get 4.702 as an answer. So I could have used either angle. It would just change which trig function I used. Okay? Okay, so I want to find the other side. Now here's something, this is just, how do I want to say this? This is a quirky thing that I believe in, okay? I like to do it using the information I was given instead of the information that I calculated. What I'm saying is, we have two sides of a right triangle. We can find the third side by using Pythagorean theorem. I'm not going to, because this side was one of the sides that I calculated. So there's two issues here. Number one, what if I made a mistake? Now my next answer will also be a mistake. Okay. Number two, this is a rounded value. So I don't want to take a rounded answer in order to find my next answer if I can avoid it. Okay. So in order to find this other missing side, I'm going to use the information that they gave me. So I'm looking for side B. Okay, I'm going to work with the 54 degrees. So I'm looking for the opposite side. I have an angle and I have a hypotenuse. Okay, so I'm going to do the sine of 54 is equal to the hypotenuse is equal to the opposite over the hypotenuse. So we're going to do 8 sine of 54 equals B. Okay, 8 sine of 54. We get 6.472. 6.472 approximately. Would I have gotten the same thing if I used Pythagorean's theorem? Well, let's check. Right, so I'd have 4.702 squared plus B squared equals 8 squared. So B squared would be 64 minus 4.702 squared. Okay. 64 minus 4.702 squared. And then I have to take the square root of that. And I get 6.472 472. Okay, we would have rounded it to the same value, but see how it's just a little bit off, right? So in this case, we would have come up with this correct value rounded to 3 places, but the actual value is a little bit off, okay? And that just bothers me. So I don't like to use rounded values when I'm calculating something because we could be off by a little bit, okay? Okay, questions so far? Okay, so the next question is going to be a little bit different. All right, so let's look at example number 5. We have the sides of a rectangle. So let's draw a rectangle. Okay, there's my rectangle. The sides of a rectangle are 8 and 25. Right, that means this is 8 and this is 25 also. What is the measure to the nearest degree of the angle formed by the short side and a diagonal of the rectangle? Okay, so I read all that. It was kind of like, what? Okay, so what I noticed is diagonal of the rectangle. So I'm going to draw diagonal of the rectangle. So there's one. I don't have to draw both of them, right? And then I'm going to read it again, see if I can figure out what they're actually asking me for. What is the measure to the nearest degree of the angle formed by the short side and the diagonal? So I'm looking for this angle right here. The angle formed by the short side and the diagonal. I'm looking for that. I'm going to call it theta. So this is different because in every problem that we've done up until now, we've been given the angle. And we were asked to find a side. This time we have the sides and we're asked to find an angle. Okay? So if I look at this triangle, look at this triangle right here. Which 2 sides do I have in relationship to that angle? Which 2 sides? Opposite and adjacent. Which trig function in SOHCAHTOA uses opposite and adjacent? Tangent. So we're going to say tangent of theta, whatever this angle is, I don't know yet, but tangent of that angle will be the opposite, which is 25, over the adjacent, which is 8. Okay. Now, in order to figure that out, we're going to do what we call take the inverse tangent of both sides. I'm trying to solve for theta. So I want theta by itself. So what we're going to do is take the inverse tangent of 25 over 8. Now this bothers people, and I understand why, okay? Because you feel like in order to get that theta by itself, you feel like you're dividing or multiplying by 1 over tangent, right? And it makes perfect sense that 1 over tangent would be tangent to the negative first, doesn't it? But it's not. Because what does 1 over tangent of theta actually equal? Cotangent. So be careful. Inverse tangent, this is called inverse tangent, is not the same as 1 over tangent. They are entirely different. Very, very important, right? When we are trying to find an angle, right? Finding an angle, we will use the inverse functions. Okay, in this case, we're using the inverse tangent. We're going to use our calculator for this. We okay so far? Okay, let's go to our calculator. if you look at the tangent button right here, okay, above the tangent is the inverse tangent. So we're going to do second tangent, and then we'll do 25 divided by 8. And that gives us 72.255 degrees. So theta equals, or theta is approximately 72.255 degrees. Okay. Yes?
So since tangent to the negative versus inverse is cotangent, why would we use 8 over 20?
So yeah, so that, be careful, right? It looks like that this would be the case, right? But it's not. These are not equivalent. Inverse tangent is not actually 1 over cosine or 1 over cotangent. Inverse tangent is not 1 over cotangent. Okay? Good question. Inverse tangent is not 1 over cotangent. Inverse sine is not 1 over cosecant. Inverse cosine is not 1 over secant. They are not equivalent, right? We're using the inverse functions to find the angles. Basically, what we're saying is the tangent of what angle, just get rid of this here, right? This equation right here, we're saying the tangent of what angle equals 25 over 8. That's what we're saying, right? Up here we had, okay, the tangent of 60 is the square root of 3. Let's turn that around, right? If I had tangent of theta equals the square root of 3, what would theta be equal to? If you had the equation tangent theta equals square root of 3, what would theta be? Tangent of what angle equals the square root of 3? 60, right? If I went on my calculator and I did inverse tangent of the square root of 3, we're going to get 60. Inverse tangent of the square root of 3, we get 60. Okay? So inverse functions are used to figure out the angle. We're trying to solve for the angle. Okay? When are the inverse functions used? When we're solving for the angle. Okay? Okay, let's see here. Okay, let's jump down to example 7. From a point 340 feet away from the base of the Peachtree Center Plaza in Atlanta, the angle of elevation, so when we talk about the angle of elevation, then, oops, I didn't want to do that. The angle of elevation, if you just think of it as this, if you were laying on the ground and looking up, that's the angle of elevation. So the angle of elevation is going to take this line here and the angle it's going to make with the ground. That's the angle of elevation. Okay? So this problem says the angle of elevation to the top of the building is 65 degrees. Find the height of the building. So we're trying to find this height right here. So what we always want to do, you look at the triangle and look at what's given, right? I have an angle. And in relationship to that angle, which side is this? The adjacent side. And in relationship to the angle, what side is this? The hypotenuse. So we have an adjacent and we have a hypotenuse. So which trig function am I using? Oh, I'm sorry, it's opposite. Holy smokes. It's the opposite. I saw the H. It's the opposite. So which trig function will I use? Opposite and adjacent. Tangent. So we're going to do tangent of 65 equals the opposite, which is h, over the adjacent, which is 340. This is what we're going to do next week when we go outside. So how do I solve for h? Multiply by 340 on both sides. So 340 times the tangent of 65. And we're going to round that just to 729 feet. That's the height of my building. Okay. We didn't have to run up the side of the building with the tape measure, right? All we had to do was measure how far we were from the building and measure the angle. Okay. Questions? How are we feeling? Give me a fist of 5. Okay. All right. Okay. Okay. So in your Google Classroom, there is a worksheet called SOHCAHTOA. There's a worksheet called SOHCAHTOA. Please complete that worksheet and upload it to Google Classroom. Okay. And you can have the rest of the period to do that.